Greetings and welcome back. Don't turn this off. You just watched a video that started with this same slide. But what we're going to be doing in this video is, instead of considering the electron's point of view, we're going to consider the chemist's point of view. Or, if you'd like to think about it this way, a human's point of view. So, when we have two things in a pot together reacting, we don't choose what they do. The electrons decide that. However, we choose what we put in the pot. So this is a much bigger point of view of the exact same video. It will be much shorter because we're going to use the exact same slides using the exact same reactions, but instead we're going to consider overall what's changing and why would we want that to happen. So from an organic chemist's point of view, the reason that we have reactions is so that we can turn molecules into other molecules. If we string together a whole bunch of reactions, we can make new things. If you want to make a new drug molecule, you have to make it from things that you have already. Well, if what we have already is, say, an alkyl halide, but the drug molecule I'm trying to make has an ether, then we need to know what we can do. And so this reaction right here, nucleophilic electrophilic substitution, lets us turn a molecule into a different functional group, into a different molecule. You'll also notice that that final product there has more carbons than we started with. This is how we can assemble things and put them together. So think about these new reactions as like tools in your kit. We have hammers to do specific things. We have screwdrivers to do specific things. We have drills and lathes, etc., etc., etc. And the reason we have all of those is so that we can build bigger things. We have little steps, but if you combine enough little steps, you can turn a pile of raw building materials into a house. But for us, we're doing this on a very, very small scale. We're still, though, starting with a pail of possible starting materials that we can buy from a chemical company, and we can build things that have never been made before. But in order to do that, we need to understand what reactions we can do. So, we can start with an alkyl halide, and we can turn that into an ether. So that is one of the tools on our toolkit. As an aside, acid-base is less useful in terms of building big things. Acid-base always just moves an H around. However, this has one really important practical purpose, which is that, let's say you have a drug molecule that has an amine in it. An amine is neutral. Neutral molecules tend to not be super soluble in water. Well, if you turn an amine into a protonated amine, or a positively charged amine, it now has a charge, and now it has an ion, and it can make ion dipole forces, or intermolecular attractions, and that makes things more water soluble. You are made out of water as a person. And so therefore, a lot of drug molecules have undergone acid-base reactions simply to give them a charge. It's still the same molecule, it just has a charge, and now it's more soluble in you, which helps to deliver a drug. All right, so that's kind of an aside for acid-base, but what we're going to see for all the rest of these reactions is that these are simply examples of functional groups turning into other functional groups. So, let's look on the left side over here. We are starting with an alkene, and we can turn it into this functional group down here at the bottom, which is an alkyl halide. This is not the only thing we can turn an alkene into. It's just one example. We will spend the rest of this year essentially adding reactions to our toolkits to let us turn alkenes into more possible things. But all of those reactions that we're going to speak about for the next 7 months or so are all going to be addition reactions, or substitution reactions, or acid-base reactions, or combinations of those things, or elimination reactions. But all of these are individually going to be tools. From the electron's point of view, they go the way that they want to. But from our point of view, we get to choose what we add to the pot. And if we add a ketone to an H minus, it will let us turn a ketone into an alcohol. We need to know exactly what we can add in order to do each of those conversions. But to me, this ends up essentially being like a puzzle. If I want to get from point A to point Z, I need to know the little things I can do in between to get there. Because not everything is a one-step reaction. A lot of times you have to string together 3 or 4 different things. But knowing those different things kind of makes it into a little bit of a puzzle. If you like puzzles, that's a good thing. Elimination is the last reaction that we saw. And so from our point of view, it's again another tool in our toolkit. It lets us start with usually an alkyl halide, but really any carbon with a leaving group. And we can add a base and turn that alkyl halide into an alkene. Alkenes and alkyl halides have a lot of different things we can do to them. And so if we can turn an alkyl halide into an alkene, we can turn an alkene into a number of different things. So from humans' point of view, and we'll look at a lot of more specific examples of this in class, we're really looking at how can we change molecules around. From the electron's point of view, they choose to do things based on where electrons want to go, if they want to be shared, if they want to be unshared, if they want to be reshared, generally going from a place that has too many electrons to a place that doesn't have enough. From our point of view, we want to see how we can change functional groups into other functional groups so that we can build new molecules. Thank you very much. I hope this makes sense. Please bring any questions you have to class, and I will see you soon.